Hello and welcome to Sleepy Interesting Facts. I'm Oliver, and tonight we're going to wander softly through space, one gentle idea at a time.
I'm Sophie, and I'll be here with Oliver, keeping the pace easy, warm, and unhurried, so you can simply listen and drift.
And I'm Dr. Patel. I'll add a few quiet details along the way, beginning with our first thought, the astonishing size of space.
So get comfortable, let your shoulders soften, and let's begin with a question that opens the door to almost every space fact. Before we start, here's the gentle rhythm. Each fact will arise slowly, like a small thought settling into a quiet room.
And if your mind wanders, that's completely fine. Just let our voices bring you back whenever you feel like listening again.
We'll keep everything plain and calm. When a big idea appears, we'll break it into smaller pieces and let it rest for a moment.
All right then, settle in. Our first stop is space itself, and the almost impossible question of how large it really is. Let the room be quiet around you now. You don't have to solve anything. You can just follow the sound of the thought.
The idea is simple enough to begin with. Space is bigger than our everyday sense of distance can easily hold.
Right, and that's why we use comparisons. A familiar distance helps the mind approach something enormous without needing to measure every mile.
If you drift off, we'll keep the thread here for you. For now, just let the vastness feel soft instead of sharp. When you think about the night sky, you're not only thinking about stars, you're thinking about distances so wide they become almost peaceful. Here's a gentle comparison. Every grain of sand on every beach still feels small beside the number of stars scattered through the universe.
The tricky part is scale, because even the nearest stars are so far away that ordinary travel times stop making sense.
Think of the solar system as a tiny neighborhood, with the planets moving around the sun and then space continuing outward far beyond it. So the night sky is not empty in the simple way. An unused room is empty. It is deep, wide, and full of distance.
Yeah, it's less like reaching the end of a hallway and more like realizing the hallway keeps stretching gently beyond what you expected.
Imagine walking for a full year. Even that feels huge to us, yet in space it would barely begin the journey between stars. And the moon, which feels so far from Earth, is actually our close neighbor compared with the distance to the sun or the nearest star. That's the cozy twist. When scale becomes too large to hold tightly, you can let it become a calm, open feeling instead.
Everyday rulers fail out here. Even light, the speed champion, needs time to cross those gaps, so scale is something you sense more than measure.
That's why astronomers use units like light years. A light year is this distance light covers in 1 year, which makes scale easier to hold.
Imagine a warm porch light across a valley, and you walk for a year to reach it. That's 1 light year, and it's only the first step.
And once you can feel that distance, the next step is natural. Those tiny points of light are not small at all. They are suns.
Space feels vast because absence does the talking. The story is written in the empty stretches between islands of matter.
A useful trick is to compare scale in your mind. If Earth were a single coin, the distance to the nearest star would be like stepping across an entire sports stadium of emptiness.
Those gaps matter because light and gravity have to travel through them. It is why the smallest events in space can take years to reach our eyes.
So, the size of space is also the size of the time we are looking across. That is what makes the night sky feel like a story you can read slowly.
Hold that sense of scale, because next, those pinpoints reveal themselves as full suns, not sparks.
And with that sense of scale in your chest, we can meet those pinpoints properly as suns in their own right, waiting to be seen anew.
Okay, quick test for your brain. If you could fly through space at a rocket speed, would you hit the edge anytime soon? Because most of the universe just keeps going.
Yeah, if you try to picture it on a planet-sized map, everything stretches. The numbers are big because the distances are truly out of this world. And that scale matters because when you say space is huge, your brain can't really measure it, so your ears just get sleepy from the magnitude. And if you try to measure space with a ruler, you quickly realize it isn't just big, it's also strangely stretchy in every direction.
Astronomers measure space with units like light years, which sounds poetic, but it's really just distance. So instead of thinking of space as one big empty room, think of it as a map of distances so vast they make Earth feel like a tiny dot.
And that is why stars help us picture scale so well. Each one is really a sun like ours, glowing from so far away that it arrives to us as a tiny point of light.
Now, let's zoom in on those tiny lights. A star is not a little spark out in space. It's a whole ball of glowing gas like our sun.
The reason they look small is distance. If you could somehow place our sun at the nearest star, it would be a pinprick.
And stars shine because their centers are hot enough for nuclear fusion. That process turns simple raw ingredients into energy.
So when you see a bright star, you're really seeing power. You're also seeing time, because the light you noticed left long ago.
Think of it as a gentle message from the past. Each twinkle is carrying a story of how that star looked when the light started its journey.
Here's a quiet way to picture a star. It's a self-powered furnace. Instead of burning wood, it uses nuclear fusion at its core, turning matter into energy.
So when we call the sun a star, we're really saying the same physics is happening, just closer to us. That closeness is why it feels bright and warm.
Let's add a little term check. Fusion means two small atoms join into a bigger one. In that joining, energy is released, like a gentle snap of release.
Because stars shine for ages, distance turns their light into a travel diary. Each glimmer tells us where it's been, not just where it is.
That's why the next idea feels important. Between these distant suns, there's a kind of cosmic quiet. Keep hold of that thought as we look at the emptiness itself.
So each star is a sun, and together they stud the dark. Between them lies a hush. We'll visit next the quiet that shapes their journeys. And that's the tricky bit. A star isn't just a dot. Most stars are suns, like our own, shining from far away.
Think of a star as a furnace with lights. It's not just twinkling points, it's a whole sun far beyond our neighborhood, burning away.
So when you see a star at night, you're not seeing a tiny light ball. You're seeing a far-off sun, with its light still traveling towards you.
So when you look at a star at night, you're not seeing a tiny light point. You're seeing a whole sun far away, long ago.
Between those stars, there's mostly emptiness, and that emptiness matters. It gives the universe room to stretch out, like a huge quiet room where the lights are spaced far apart. Here's the plain truth. Most of space is empty of stuff you'd bump into. What exists is spread so thin it whispers rather than shouts.
If you hold two magnets apart by a few steps, you can feel the gap. In space, the gaps are so large that forces become faint, quiet, and slow.
There is matter out there, of course, gas, dust, and lots of tiny particles. But compared to the huge volume, they're like a few specks in a very large room.
Picture a huge football stadium at night, where every seat is empty and the lights are far apart. That's the feel of space's spacing.
And this emptiness matters for the story of motion because objects can travel for a long time without bumping into much at all.
So, empty means thinly scattered matter is there, just far apart, like snowflakes drifting miles from one another.
A gentle term check helps. Density is how much material is packed into a space. In space, the density is tiny, so long stretches feel quiet.
And that thinness changes how light travels. It can move far without getting scattered, which is why we can see galaxies as distant pinpoints.
So the emptiness is part of what allows long journeys. Planets can keep their orbits for billions of years with barely any drag.
Now, holding on to that idea, the next fact is like the movement you get when gravity has room to act. Planets orbit stars in steady patterns.
Hold that quiet in mind. Now watch what gravity does with room to work. It sketches paths, and those paths become orbits around the light.
So, even when it feels busy in pictures, space is mostly a vacuum. Particles are so spread out that distances matter more than stuff.
And the wild part is that between those distant dots there's a lot of nothing. Not silence exactly, but extreme emptiness.
That quiet room also gives planets their paths. They orbit stars in steady curves, moving like patient dancers around a bright center they can never quite leave behind.
Think of orbits as the calm habit of planets. They return again and again, tracing reliable curves around their star.
Imagine you're holding a ball on a string and you let it swing. It doesn't fly off, and it doesn't drop straight down either. It keeps bending around.
In space, gravity plays the role of that inward pull. The planet also has forward motion, so the path becomes a curve.
An orbit isn't a painted track. It's the balance between forward motion and gravity, always negotiated, never fixed.
Understanding orbit shows how systems stay tidy for ages, order from simple rules. Fling a planet and it drifts, add gravity side nudge and it curves, staying near its star.
An orbit isn't a perfect circle, it's a looping dance shaped by the tug and the glide.
Think of it like sailing. You're always moving, yet the water and wind shape your route. The planet's route is shaped by gravity, not by rails.
That's why orbits feel reassuring. Even in a universe with so little to hold onto, the motion can be steady and predictable.
And once you know that planets orbit, the next fact becomes a gentle head count. Our solar system has specific worlds on specific paths.
With orbits clear, we can tour our family, 8 main worlds circling one star. We'll meet them gently, starting close to the sun.
To picture it, think of an invisible loop made by gravity. The planet keeps missing the star, and that miss turns into an orbit. Our own solar system follows that same calm pattern. The sun sits at the center and 8 planets travel around it: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune.
Let's step into our own neighborhood. The solar system is a family circling the sun. Planets, moons, and smaller travelers keep the story moving.
They're not all the same kind either. Some are smaller and rockier, and some are huge and made mostly of gas.
The inner planets, like Mercury and Mars, are closer to the sun and tend to be tougher because there is less cold material there.
Then the outer planets, like Jupiter and Saturn, grow big and keep thicker atmospheres. It's as if the cold outer part lets them collect more.
When you know the planet groups, the next facts start feeling like a gentle tour, not a list.
Inner worlds loop quickly with short years. Far-out giants take their time. Distance sets each world's tempo.
A planet is a world that orbits the sun and is rounded by its own gravity enough mass to pull itself into shape.
Beyond the 8 main planets, we also meet moons, asteroids, and comets, smaller neighbors sharing the sun's wide lanes.
That pattern matters because it helps place Earth just far enough from the sun for liquid water to persist.
Now, with this neighborhood in mind, the next fact becomes personal because one planet among them earns the title of home for living things.
With the family sketched, let's step close to the one that feels like home Earth, where life quietly takes hold. And just like that, our neighborhood gets a name you can count on. 8 planets plus the sun, moons, and a whole crowd of smaller worlds. Earth is the one we know best because it supports life in all its forms. Plants, animals, and people all share this gentle world, which makes it feel especially precious. Home feels special because life rises in many forms, quietly adapting to seas, soils, and skies.
Life here can use sunlight, liquid water, and an atmosphere that helps keep temperatures steady enough for living things to manage.
Earth also has a protective atmosphere and an active planet interior. Those two together help create conditions that last for long periods.
Imagine a quilt of oceans, clouds, and land. It shifts with seasons yet keeps the planet comfortable.
And once you think about living things, the next detail becomes easy because water is a big part of the story of Earth. Let's make Earth feel real in one breath. It has the right ingredients arranged gently: air, liquid water, and a steady supply of energy from the sun.
Atmosphere is the blanket of gases around a planet. For Earth, it steadies temperature and filters harsh radiation.
And liquid water matters because it lets chemistry happen. Think of it like a slow, patient mixing bowl where reactions can keep going for a long time.
Once you've got life's ingredients, the next clue is Earth's color from far away. That's where water takes the lead.
So Earth isn't special because it's loud or obvious. It's special because conditions line up in just the right quiet way.
From above, one clue to Earth's living comfort is its color. Let's follow that blue across the seas.
So what makes Earth feel different? It is not the size first, it is the mix of water, air, and energy that life can actually use. From space, Earth often looks blue, and that's mostly because of the water on its surface. Oceans reflect and shape the light, giving our planet that soft and familiar glow.
From orbit, blue dominates because oceans cover most of Earth's surface. Land and cloud weave pale accents around it.
When sunlight reaches the ocean, the water absorbs some colors and leaves the blue ones to travel back towards space.
There's also the way waves and clouds sit above it, scattering light in gentle ways that make the blue feel softer.
Picture it like a big blue mirror, but one that's never still. The ocean moves, and that movement helps the color look alive.
And because water matters for life, that blue is a quiet clue about why Earth is such a welcoming place.
Let's zoom in on that blue. From space, Earth's water covers a lot of the surface, so it becomes the easiest color for our eyes to catch.
Think of sunlight like confetti in air and water. The blues are the pieces that most often flutter back toward your eyes.
Clouds and the air smooth the view into one gentle marble. Details blur into a single blue impression.
And here's the why it matters moment. Water isn't just pretty, it supports the sort of chemistry and climates that make life possible.
Now, if water is a star in Earth's story, the next fact adds a gentle partner to that water, the moon, pulling and guiding it over time.
And if water is Earth's paint, the moon is the steady hand that moves its brush from night to night. And here is the cozy part. When sunlight hits oceans, the water scatters the light in a way that favors blue hues.
The moon moves around Earth in a steady path like a quiet neighbor in the sky. It changes appearance through the month because sunlight falls on it from different angles.
Let's drift to the moon. It doesn't just sit there, it orbits Earth, traveling in a steady loop again and again.
Because it orbits, the angle changes. Sometimes we see more of the moon's sunlit side, and sometimes we see less.
The moon is a steady companion in motion. Gravity keeps it bound, and the changing angle changes what we see.
So, when you see a crescent, you're not looking at a different moon, you're just catching it in a different part of the same orbit.
And once you understand that orbit, the next step is easy. The moon's gravity does more than shape its own phases.
It circles Earth in about a month, so our view cycles through familiar shapes again and again.
Those monthly loops give the phases their names: new, crescent, quarter, gibbous, full, then back again.
That's why we get crescents and half moons. It's not a changing moon, really. It's mostly our view of which part is lit by sunlight.
And there's a calm bridge to the next idea. When bodies orbit, their gravity still reaches out. That gentle pull is what starts shaping the oceans.
So the moon is like a slow metronome in the sky, keeping time for Earth's tides. Hold that gentle pull in mind. Soon we'll feel how it tugs at the oceans themselves.
So it is not floating out there at random, it is actually circling Earth, guided by gravity like a slow cosmic dance.
And the moon does more than brighten our nights. Its gravity gently tugs on Earth's oceans, and that soft pull helps create tides, moving the seas in a slow rhythm. Alright, let's follow the moon's pull. Tides are not the moon pushing the sea like a hand. It's more like a gentle difference in pull across Earth.
The moon's tug isn't a shove, it's uneven across Earth's oceans, and that unevenness is the quiet heart of tides.
That difference stretches the ocean shape. Water responds by slowly building up into bulges and then easing away again as the moon moves.
So when you notice the tide coming in and out, you're really watching Earth and moon keep a slow, steady rhythm together.
And it's wonderfully calming to know it has a cause, because the ocean's motion is predictable when the pull is steady.
Let's make tides feel intuitive. Think of the ocean as a huge, flexible layer on Earth's surface, not as something rigid.
Tides come from tidal forces, which is the difference in gravity across an object. The side nearer the moon feels a stronger pull.
So the ocean stretches. As Earth turns, different places move through that stretched shape, and that's what we experience as high and low tide.
Why it matters is simple. Tides influence coastlines, help mix nutrients, and even nudge the rhythms of marine life.
And once you've felt gravity's pull on water, it's a small next step to follow another source of energy, the sun that drives weather and life.
With the ocean's slow pulse in mind, let's turn toward the source of daylight itself, the sun. Oh, and those tides come from the moon pulling a slightly different amount on the near side and the far side of Earth.
Then there's the sun, our nearest star and the source of daylight and warmth. Without it, Earth would be cold and dark, so its light feels like the start of every morning.
Let's make the story brighten. The sun is our nearest star, and it gives Earth light and warmth every day.
Because the sun is always producing energy in its hot center, it keeps sending out light like a steady lantern that never runs out.
That sunlight powers photosynthesis, so plants can grow. From plants, a whole chain of life can begin.
So when you feel warm in the morning, you're feeling the sun's energy arriving and doing its quiet work across the day.
And in a moment we'll follow that light, because it doesn't appear instantly. It travels across space first.
Now let's trace a single ray across space. It needs a few quiet minutes before it reaches us. If the sun warms our mornings, your tap warms this tiny show. Subscribe and like to charge our sleepy solar panels. Huh.
Got a favorite sky color? Dawn gold, midnight blue? Drop a comment below and tell us. We'll peek between constellations.
That sunlight doesn't arrive instantly, though. It travels across space first, which means every warm ray has already been on a journey before it reaches your face.
Now for the travel time. Light doesn't teleport from the sun to you. It goes on a journey, and that journey takes time.
So when we see the sun, we are seeing it as it was a little while ago. It's a gentle reminder that now in space can be delayed.
For our sun, it's only about 8 minutes. That's still long enough that the sun could change while the light is on the way.
And that idea extends outward. When we look at distant stars, we are looking back through time because their light has a much longer trip.
It's a comforting thought, almost like receiving a postcard that was written long ago and still arrives. And that traveling light also paints the planets differently, which is where we're heading next.
As sunlight reaches different worlds, it helps reveal their personalities too. Some planets look rocky, some cloudy, and some are striked with storms that never seem to settle. Yeah, and this is a fun one, because different is really what your eyes notice first.
When we say albedo, we mean how bright a surface looks, like a ball reflecting more or less light.
And the color isn't random. Clouds, dust, ice, and gases filter sunlight in their own way, so the planet's atmosphere becomes a tinted lens.
So, why it matters in everyday life is that we can study distant worlds without touching them, just by decoding their light.
For a simple comparison, think of wearing different colored glasses. The world behind them looks altered, even though nothing moved.
Next, when we zoom in on specific planets, those looks help explain their surprising behavior, like fast Mercury and glowing Venus.
Let's start the tour close in, with swift Mercury small, cratered, and quick around the sun.
Mercury is the closest planet to the sun, so it moves quickly and keeps close to the heat. It's small, swift, and a little dramatic in that bright neighborhood.
Mercury is a small rocky world, and because it stays closest to the sun, its year is very short. It loops around our star much faster than Earth does.
That closeness also means Mercury gets intense sunlight. But interestingly, it does not have a thick blanket of air to hold heat in place.
So one side can grow very hot in sunlight, while the darker side becomes much colder. It's a bit like a stone warming in sunshine, then cooling quickly at night.
Mercury also looks a little like our moon, with a surface full of craters from old impacts. It feels more rugged and bare than the cloud-covered planets nearby.
That matters because Mercury shows us what a stripped-down rocky planet can be like. By studying it, we learn more about how the inner solar system formed long ago. Venus comes next, glowing beautifully from far away. Under those thick clouds, though, it traps heat so well that it becomes the hottest planet in the solar system.
Venus may look lovely in the sky, almost like a bright jewel, but it is actually one of the harshest places in the solar system. Looks can be wonderfully misleading.
Its thick clouds trap heat so well that Venus is even hotter than Mercury, even though Mercury is closer to the Sun. Well, that's a surprising twist, isn't it?
Scientists call that heat-trapping effect a greenhouse effect. On Venus, it is extreme, so warmth builds up and has a very hard time escaping back into space.
You can picture Venus like a world wrapped in a very thick blanket that never comes off. Instead of cooling gently, it stays hot all the time under those clouds.
Venus matters because it reminds us that a planet can be similar in size to Earth and still turn out completely different. And after Venus, we come back home to Earth. Earth stands apart because it has one moon, and that single companion gives our night sky a steady rhythm. It's a simple detail, but it makes our world feel wonderfully balanced.
That one moon might sound simple, but it makes Earth feel especially familiar. When we look up at night, we are seeing our planet's steady, natural companion.
Some planets have many moons, but Earth has just one large one, so it feels less like a crowd of companions and more like a single bright partner in the sky.
Our moon helps shape the rhythm of nights, months, and even some ocean tides. It's amazing how one nearby world can quietly influence life on Earth.
Compared with Earth, the moon is much smaller and has no thick atmosphere, no weather, and no seas like ours. It is rocky, dry, and far quieter than home.
And that matters because the moon gives scientists clues about Earth's early story too. From this calm pair of worlds, we can gently step onward to reddish Mars. Mars follows with its rusty red color, caused by iron-rich dust on the surface. It looks almost like a quiet ember drifting through space, which is why it feels so memorable.
Mars gets its red look from rusty dust, which is dust rich in iron. So in a gentle way, Mars is a planet that appears tinted by something like rust.
That color does not mean Mars is glowing red on its own. It simply reflects sunlight from a surface covered with reddish minerals and fine dust.
If Earth can look blue because of water, Mars can look red because of its dusty ground. That makes the two planets feel very different at just one glance.
Mars matters to us because it seems both familiar and distant. It has seasons, ice, and weather, yet it is much colder and drier than the world we know.
That mixture of familiarity and difference is why Mars is studied so closely. And as we travel farther outward, the next world grows far larger, Jupiter. Then we reach Jupiter, and the scale suddenly grows enormous again. It's the largest planet, a vast gas giant with swirling clouds that make the smaller worlds seem delicate by comparison.
Jupiter is so large that all the other planets feel smaller beside it. It is a giant world made mostly of gas, with no solid surface to stand on.
When people call Jupiter the largest planet, they really mean enormous on a hard-to-picture scale. You could fit many Earths inside it and still have room to spare.
Its clouds form bands and storms, including the famous Great Red Spot. That storm has lasted a very long time, far longer than any storm we usually imagine on Earth.
So if Earth feels like a small home, Jupiter feels more like a whole moving sky wrapped into a planet. Everything about it seems bigger, deeper, and more powerful.
Jupiter matters because giant planets help shape the structure of the solar system. And after that enormous world, we drift toward one of the prettiest sights of all, Saturn. Saturn is the next beautiful surprise, with rings that seem to float around it like a soft halo. Those rings are made of countless icy pieces, each one catching the light in its own quiet way.
Those rings are not solid hoops, even though they can look that way from far off. They are made of countless pieces of ice and rock orbiting Saturn together.
That makes Saturn feel a bit like a planet wearing a shimmering halo. The pieces are separate, but from a distance they blend into bright, graceful bands.
Other planets have rings too, but Saturn's are the most dramatic and easy to notice. They spread wide and catch sunlight in a way that feels almost delicate.
A useful comparison is a swarm of tiny icy objects moving in order, not a single flat plate. That helps explain how something so grand can also be made of small parts.
Saturn matters because it shows how beauty in space can come from motion and structure together. And after those rings, the next planet surprises us by spinning sideways. Uranus is another gentle mystery because it spins on its side instead of upright. That strange tilt makes it feel like a planet that chose an entirely different path.
Most planets spin more or less upright, but Uranus is tipped over so much that it seems to roll round the sun on its side. That makes it wonderfully unusual.
Well, imagine a spinning top lying almost flat instead of standing tall. That simple picture helps explain why Uranus looks so different from the other major planets.
Because of that sideways tilt, Uranus has very unusual seasons. Parts of the planet can spend long stretches facing the sun, then long stretches turned away.
Compared with Earth's gentle seasonal changes, Uranus feels extreme and slow. Its whole pattern of sunlight is arranged in a much stranger way than ours.
That matters because Uranus reminds us planets can form or change in surprising ways. And farther out still, Neptune waits with deep blue color and fierce winds. And Neptune, far out near the edge of the solar system, is deep blue and very windy. It looks peaceful from a distance, yet its skies move with astonishing speed.
Neptune's deep blue color makes it seem calm and dreamy from far away, but it is actually a very active world with some incredibly fast winds.
So Neptune gives us a gentle lesson in not judging a planet by its color. It may look peaceful, yet its atmosphere can move in powerful, stormy ways.
That blue color comes partly from gases in the atmosphere that absorb some colors of sunlight and reflect others. In a simple sense, the planet filters light differently from Earth.
If Earth's blue can remind us of oceans, Neptune's blue is more like a cold, distant jewel. It is beautiful, but also much farther, darker and wilder.
And Neptune matters because it shows that even the far edge of our solar system is full of motion and surprise. Beyond it, we begin meeting smaller worlds like dwarf planets. Beyond Neptune, we meet dwarf planets, which are smaller worlds still orbiting the Sun. Pluto is the famous one, and it reminds us that the solar system has many kinds of residents.
A dwarf planet is a world that orbits the Sun and is round from its own gravity, but it has not cleared away other objects near its path.
That means it is planet-like in some ways, but not quite in the same category as the 8 main planets. Pluto is the best-known example.
You can picture dwarf planets as smaller members of the solar system family, still important, just not the biggest ones in the neighborhood around the Sun.
That idea is interesting because it shows space is not just divided into planets and everything else. There are gentle, in-between kinds of worlds too.
And once we meet dwarf planets as a group, it feels natural to drift toward one famous member of that family, distant and icy Pluto.
Pluto itself is distant and icy, with sunlight so faint that everything there feels slow and hushed. It's the kind of place that makes the edge of the solar system feel very far away indeed.
Pluto is so far from the Sun that sunlight there is much weaker than it is on Earth. The whole place feels dimmer, colder, and much more remote.
It is called icy because frozen materials, including nitrogen and water ice, can stay on or near its surface. Well, it is more like a frozen frontier than a warm world.
If Earth is a lively blue home, Pluto feels like a tiny pale outpost at the edge of the family. It is quiet, cold, and very far away.
That is what makes Pluto so interesting. Even a small, distant world can have landscapes, seasons, and a real story of its own.
And once we move past Pluto's frozen calm, we start noticing other smaller travelers too, including the rocky objects we call asteroids. Around that outer region, we also find asteroids, which are rocky objects moving through space. They're smaller than planets, but they still play a busy part in the solar system's story.
An asteroid is a rocky object in space that is smaller than a planet. Some are tiny like pebbles, while others are large enough to be little worlds.
They orbit the Sun just as planets do, but they do not dominate space around them the way planets can. So they are more like scattered pieces than major worlds.
One vivid example is that some asteroids are oddly shaped because they are too small for gravity to pull them into neat round balls. They can look rugged and lumpy.
That makes asteroids interesting because they are like old building stones left over from the solar system's early days. They can preserve very ancient material.
And if asteroids are the individual rocks, the next step is to visit the broad region where many of them travel together, the asteroid belt. Between Mars and Jupiter lies the asteroid belt, a broad region filled with many rocky bodies orbiting the Sun. It's less like a crowded wall and more like a wide, scattered path.
The asteroid belt is a wide region between Mars and Jupiter where many rocky objects orbit the Sun. It is more spread out than people often imagine.
It is not like a crowded wall of tumbling rocks. Most asteroids are actually very far apart, with lots of empty space between them.
A helpful way to picture it is as a broad lane around the Sun, sprinkled with rocky travelers. It is a region, not a solid ring you could walk across.
This region is interesting because it holds clues to the early solar system, where material never fully joined into one large planet. The story stayed unfinished there.
And from those rocky leftovers, we can drift to another kind of visitor entirely, because comets bring ice and glowing tails into the story. Comets are different again, because they're icy visitors from the colder outer reaches. When the sun warms them, they release glowing tails that stretch behind them like a bright ribbon.
A comet is a small icy body that travels around the sun. When it comes closer to the sun, some of its frozen material warms up and begins to stream away.
That streaming material forms the glowing tail, so the tail is not something a comet always has. It appears most clearly when sunlight and heat affect the comet.
You can picture a comet like a dusty snowball flying through space, suddenly growing a shining veil when it nears the sun. It feels delicate and dramatic at once.
Comets are interesting because they carry ancient frozen material from the colder outer solar system. They can tell us about what the early solar system was made of.
And once a glowing comet passes through our imagination, the next bright streak in the sky is easier to understand too. A meteor or shooting star. Sometimes tiny pieces of rock or ice enter Earth's atmosphere and blaze across the sky. We call that streak a meteor, and from the ground it can look just like a shooting star.
A meteor is the streak of light we see when a small bit of space material rushes into Earth's atmosphere and heats the air around it. That glowing streak is the meteor.
So a shooting star is not really a star at all. It is usually a tiny piece of rock or dust making a brief bright line across the night.
One vivid example is a meteor shower, when Earth passes through a trail of debris and many meteors appear over the course of a night. It can feel wonderfully magical.
Meteors are interesting because they show how Earth is still moving through a busy solar system, even when the sky seems quiet and still.
And sometimes that glowing visit does not end in the sky, because a surviving piece can continue downward and become a meteorite on Earth. If part of that object survives the fiery trip and lands on Earth, then it becomes a meteorite. It's a small visitor from space that managed to reach us all the way down.
A meteorite is a piece of rock or metal from space that survives its trip through the atmosphere and reaches the ground. That is the key difference from a meteor.
So the glowing streak happens in the sky, but the meteorite is what is left if part of the object makes it all the way down to Earth.
One vivid example is a dark stone found after a fireball passes overhead. It can look ordinary at first, yet it may have traveled through space for ages.
Meteorites are important because they give scientists real pieces of the solar system to study by hand. They can reveal what ancient space material is made of.
And most of the time, thankfully, Earth's atmosphere stops much smaller objects before they ever reach the ground, which leads us to our next gentle fact. Most of the time, though, Earth's atmosphere does the protecting. It burns up many of those incoming bits before they can reach the ground, quietly shielding everything beneath it.
Earth's atmosphere is the layer of gases wrapped around our planet. It helps protect us in more ways than we usually notice during an ordinary day.
One important job is that it burns up many tiny incoming bits of space material before they can reach the ground. In that sense, it acts like a gentle shield.
It also helps hold warmth, carries weather, and gives us air to breathe. So this invisible blanket is doing many quiet jobs all around us.
A good picture is to imagine Earth wearing a protective coat. We cannot usually see the coat itself, but we notice the safety and comfort it provides.
And that same atmosphere can help create something beautiful too, because near the poles it glows with soft moving lights called auroras. That same atmosphere can also help create auroras near the poles. They're soft curtains of color in the sky, and they feel almost like the planet is putting on a private light show.
An aurora is a glow in the sky that appears when energetic particles from space meet gases high in Earth's atmosphere. The result is a soft moving light show.
They are often seen nearer the poles, where Earth's magnetic field helps guide those particles downward, so the sky can shimmer with green, pink, or purple curtains.
One vivid example is the northern lights, which can ripple across a dark sky like glowing fabric being gently shaken. It is science, but it feels almost dreamlike.
Auroras are interesting because they reveal that Earth is not cut off from space. Our planet is quietly interacting with the sun and the space around it.
And after those beautiful lights, we can turn to the force behind so many patterns in space and on Earth: gravity. Gravity is the gentle force behind so much of this movement. It keeps us on the ground, the moon around Earth, and the planets circling the sun in their patient, curved paths.
So what is gravity really? It is the pull that mass has on mass, which is a simple way of saying that things with matter attract other things with matter.
That is why our feet stay on the ground. The moon stays near Earth, and planets stay near the sun. The same idea works from small scales to huge ones.
You can picture gravity like an invisible hand that never stops gently tugging. We do not see the hand itself, but we notice its effects everywhere.
And why does it matter so much? Because without gravity, air, oceans, moons, and planets would not stay gathered in the calm patterns we know.
Once gravity is in place, the next question follows naturally. If gravity pulls things inward, how do worlds keep moving around instead of simply falling straight in?
Those curved paths are called orbits, and they're simply the routes objects follow because of gravity. Once you picture it, space starts to feel less random and more like a quiet dance.
That is a lovely question, because an orbit is really a kind of falling that keeps missing. The object is pulled inward, but it is also moving sideways.
So instead of dropping straight down, it keeps curving around. Right, that is why planets trace long looping paths around the sun.
Orbit simply means the repeating path an object follows because gravity bends its motion. The curve comes from that balance between forward motion and inward pull.
A simple picture is throwing a ball so fast that instead of landing nearby, it keeps falling around the Earth. It is still falling, just in a circle-like path.
And once you understand orbits, it feels easier to zoom outward, because our planet's path around the sun is only one tiny motion inside a far larger home, the Milky Way.
All of that motion happens inside the Milky Way, our galaxy. It's a huge collection of stars, gas, and dust, and our solar system is only one small corner of it.
So, what is a galaxy? It is a vast collection of stars, gas, dust, and dark matter all held together by gravity over enormous distances.
Our own galaxy is called the Milky Way, and it is the giant home that contains the Sun, Earth, and all the planets we have been talking about.
That means the solar system is not floating alone. It is one small neighborhood inside a much larger city of stars.
A helpful image is to imagine a softly glowing spiral with many starry lanes. We live inside one part of that grand structure, not outside looking in.
And once the Milky Way feels real, the next question opens by itself. If one galaxy is this immense, how many stars might a galaxy hold? And the Milky Way itself is only one galaxy among billions. When you think about that, the universe starts to feel beautifully vast, almost beyond tidy counting.
The answer can be astonishingly large. A galaxy can contain billions, and sometimes even more, individual stars gathered into one enormous system.
So when we look at the Milky Way as a misty band in the sky, we are really looking at light from a huge crowd of stars blended together.
That is hard to picture, isn't it? Well, it helps to think of a beach where one glance shows a smooth shore, even though it is made of countless grains.
This matters because it reminds us how small one solar system is compared with a galaxy. Our sun is only one star among a vast population.
And once billions of stars in one galaxy starts to feel real, the next step is wonderfully bigger still, because the universe holds many galaxies, not just ours. Some galaxies contain billions of stars, each one with its own history and its own little neighborhood of planets. It's like looking at one city and realizing the whole cosmos is full of them.
Yes, and that means the Milky Way is only one island in an ocean of galaxies. The universe is not built around our galaxy alone.
So a galaxy is like one great city of stars, and the universe contains countless other cities spread across enormous distances. It is a peaceful thought.
Some galaxies are spiral, some are oval, and some are irregular in shape. They can differ greatly, yet they all help show how varied the cosmos can be.
A vivid comparison is to imagine looking across a dark sea at many faraway lanterns, each one marking a different island. Each one marking a different island. Each lantern, in this case, is a whole galaxy.
And among some of those galaxies, in their deep, mysterious regions, we find places where gravity grows so strong that it leads us naturally toward black holes.
Inside some of those galaxies, black holes form where gravity becomes extremely strong. They're not little sucking machines, just regions where matter is packed so tightly that even light struggles to escape.
So what is a black hole exactly? It is a region of space where so much mass is packed together that gravity becomes extraordinarily strong.
That does not mean it is a giant hole like a tunnel in the ground. It is more like a place where space has an especially deep gravitational pull.
If an object gets too close, escaping becomes very difficult because the pull is so intense. That is why black holes feel both scientific and mysterious.
A gentle picture is to imagine a valley so deep and steep that rolling back out becomes almost impossible. Gravity is doing the work in that comparison.
And once we understand that extreme pull, the next question almost asks itself, if gravity is that strong, what happens even to light when it comes too close? That's why black holes seem so dark. If light can't get out, then our eyes have nothing to catch, which makes them feel hidden and mysterious.
Light is the fastest thing we know. So when people hear that it cannot escape a black hole, that is what makes the idea feel so astonishing.
So is the black hole grabbing light like a hand? Not exactly. It is more that space near it is shaped so extremely that the path outward is no longer possible.
That is why black holes appear dark to us. If light cannot get back out, then there is nothing there for our eyes or telescopes to directly collect.
One gentle way to picture it is a waterfall with a point beyond which even the fastest swimmer cannot return upstream. Past a certain boundary, escape is no longer possible.
And after visiting one of the most mysterious ideas in space, it feels soothing to turn from that darkness back toward beginnings, where stars are born in clouds of gas and dust. Yet the story of stars begins much earlier, in clouds of gas and dust drifting through space. Over time, those clouds gather together, grow warmer, and slowly begin to shine.
A star begins when a cloud of gas and dust slowly gathers under gravity. Over a very long time, that material becomes denser and warmer at the center.
Those clouds are often called nebulae, and they can be enormous. Even though they look soft and misty, they hold the raw material for future stars.
You can picture it like a gentle swirl of cosmic fog slowly drawing itself inward. Little by little, the middle grows tighter, hotter, and brighter.
That matters because star birth is really the beginning of many later stories, including planets, moons, and eventually the materials that can build new worlds.
And once a star is born, it does not stay exactly the same forever. The next gentle step is to follow how stars change across their long lives. Stars don't stay the same forever either. They're more like long-lasting stories, changing slowly as they use up their fuel and move through different stages of life.
Once a star is shining steadily, it can stay that way for a very long time. But, well, stars are not frozen in one stage forever.
They slowly use up the fuel in their hot centers, and that changes how they behave over time. So a star has a life story, not just a single moment.
That is why astronomers talk about stellar life cycles. A life cycle is simply the sequence of stages something passes through from beginning to later change.
A useful comparison is a tree growing from a seed, then maturing and later changing again. The timing is far slower for stars, but the idea of stages still helps.
And one of the most striking later stages for some stars is when they swell outward and become red giants, which is where our story drifts next. Later on, some stars swell into red giants. They grow much larger, glow a softer red, and feel like the quiet beginning of a grand final chapter.
A red giant is a star that has expanded outward late in its life. As its outer layers swell, the star can grow much larger than it was before.
It also looks redder because its outer surface becomes cooler than it was in its earlier stage. Cooler here still means extremely hot, just less hot than before.
You could imagine a glowing lantern with its light spread over a much larger shape. The star becomes broader and softer looking, though still powerful.
This stage matters because it shows that stars can dramatically reshape themselves as their fuel changes. A star's later life can look very different from its beginning.
And for the most massive stars, the story can become even more dramatic still, because some do not just swell, they end in brilliant explosions called supernovae. For massive stars, that final chapter can be a supernova, a brilliant explosion that sends energy and material out into space. It's dramatic, but it also helps seed the next generation of stars.
A supernova is an enormous stellar explosion that can happen at the end of a massive star's life. For a short time, it can shine with astonishing brightness.
It may sound destructive, and it is dramatic, but it is also creative in a cosmic sense. Explosions like this send material outward into space.
You can picture a supernova like a great burst of starlight, scattering matter into the dark around it. It is a powerful ending that also becomes a beginning.
That matters because the materials flung out by stars can later help form new clouds, new stars, and even future planets. Space keeps recycling its ingredients.
And after such an explosion, one beautiful result can be a glowing cloud in space, which leads us naturally to nebulae. The material left behind can become a nebula, a glowing cloud of gas and dust. Nebulae are beautiful because they can drift for ages while quietly preparing the ingredients for new stars.
A nebula is a cloud of gas and dust in space, and some nebulae glow with beautiful color when nearby stars light them up. They can look soft, bright, and almost painted.
So a nebula is not just decoration in the sky. It can be part of a star's ending or part of the material that helps new stars begin.
That is why nebulae fit so well in the story of change. They can hold leftovers from older stars while also becoming the cradle of future ones.
A gentle picture is a glowing cloud drifting in darkness, slowly carrying the ingredients for another round of cosmic building. It feels both peaceful and important.
And inside those clouds, even the tiniest grains matter, because cosmic dust helps turn loose material into the seeds of new worlds. Tiny dust grains inside those clouds can slowly clump together too. Bit by bit, space builds bigger things from small beginnings, which is a rather lovely thought.
Cosmic dust may sound tiny and unimportant, but those grains can gather, stick, and slowly build into larger pieces over immense stretches of time.
So dust is not only what is left behind, it is also part of what comes next, helping loose material become pebbles, rocks, and eventually much larger bodies.
A helpful comparison is flour in dough, where many tiny particles blend into something bigger and more solid. Space builds slowly, but the idea is a bit like that.
That matters because planets, moons, and other worlds do not simply appear all at once. They grow from countless small beginnings joining together.
And after following those ingredients from starbirth to new worlds, our next step feels fitting because spacecraft help us explore the universe that made them.
One gentle detail people often miss is that dust grains do not stay perfectly alone. In cold clouds, they can brush together, cling, and slowly begin forming larger little clumps.
Yes, and around a young star, those grains often spread into a broad spinning disk. That disk is like a patient workshop where future worlds begin taking shape grain by grain.
So instead of planets popping into existence all at once, they begin in a soft ring of dust and gas, almost like ingredients circling in a quiet cosmic bowl.
As bits collide, some break apart, but others stick well enough to keep growing. Over very long stretches of time, tiny pieces can become pebbles, rocks, and then something much bigger.
Gravity helps with that next step. Once a growing body becomes massive enough, it pulls nearby material inward a little more strongly, which lets the building process continue.
I like that picture because it makes planet formation feel less like magic and more like a slow, sleepy gathering where the universe keeps adding one small piece at a time.
And not every grain ends up in a planet, of course. Some stay as dust, some join moons or asteroids, and some keep drifting as leftovers from that ancient construction.
That's where spacecraft come in, because they let us travel beyond our own planet and study those distant places directly. They carry our curiosity into the wider universe and bring the answers back.
Well, spacecraft matter because most of space is far too distant, cold, or airless for people to simply wander through on their own. Machines can go where our bodies cannot.
Some orbit planets, some fly past them, and some land. Each kind of mission is designed to answer a different question, almost like sending the right tool for the right job.
And they are patient travelers too. A spacecraft can spend months or even years crossing the dark, just to arrive and quietly collect a few precious clues.
Those clues might be photographs, temperature readings, maps, or samples of light and dust. Each measurement adds a little more detail to places we cannot touch ourselves.
They also protect us from risk. Before humans ever visit a harsh place, robotic missions can study radiation, weather, and terrain, helping us understand what that world is really like.
So a spacecraft is not just a vehicle, it is more like our careful stand-in, carrying our instruments, our questions, and a little bit of human curiosity into the silence.
And when one of those spacecraft actually lands and begins moving across the ground, that is when the story becomes especially charming, because then we meet the rover.
Rovers are one part of that story, rolling carefully across other worlds like Mars. They examine rocks and soil up close, almost like little explorers with very patient feet.
Telescopes help too, because they gather light from faraway objects and make them easier to study. They don't bring space closer, but they do bring more detail to our eyes.
One quiet reason telescopes help so much is that they do not merely make things look bigger. They also gather more light than our eyes can collect on their own.
So if your eye is like a small cup catching raindrops, a telescope is more like a wide bowl, holding on to many more drops from a faint and distant glow.
That extra light matters because many stars, nebulae, and galaxies are simply too dim for bare eyes, even though they are there all along, waiting in the dark.
A larger mirror or lens can collect light for longer and from a wider surface, which lets soft details slowly rise out of the black background.
People often think of magnifying first, but clarity is just as important. A good telescope helps separate tiny points of light that would otherwise blur together.
In a gentle way, it is like cleaning a foggy window. The view may still be far away, but its shape becomes steadier, sharper, and easier for the mind to understand.
And when astronomers attach cameras, they can let light build up over time, almost the way your eyes adjust in a dim room and begin noticing what was hidden before.
Observatories give those telescopes a quiet home, often high up or far from city lights. In those peaceful places, people can watch the sky with far less distraction. Well, an observatory is really a place designed to protect seeing itself, because even a small amount of city light can wash faint stars out of the sky.
That is why many observatories sit on mountaintops, in deserts, or far from bright towns, where the air can be darker, drier, and a little steadier.
If the air is wobbly, starlight wiggles before it reaches the telescope, and the view can shimmer. Quiet skies help the picture settle down.
Some observatories also watch night after night for years, which is useful because space is full of slow changes that only reveal themselves with patience.
A star may dim slightly, a comet may return, or a distant planet may pass in front of its star, and those tiny patterns matter deeply to astronomers.
So an observatory is not just a building with a dome. It is more like a long, careful diary of the sky, written in light.
And that steady watching helps people compare one season with another, which gently leads us to how the night sky itself seems to shift through the year.
As Earth moves around the sun, the night sky changes little by little through the year. Different stars and planets become easier to see at different times, which keeps the sky feeling alive. As Earth travels around the sun, the nighttime side of our planet gradually faces different directions in space, so different groups of stars come into view.
So the sky is not swapping stars in and out exactly. We are the ones moving, and our window into the wider universe slowly turns over the months.
That is why a constellation you notice on a winter evening may be missing from a summer one, even though those stars are still calmly shining where they always are.
It can help to picture walking in a circle inside a dark room with lamps around you. At each point, your view changes a little.
The change feels gentle because Earth moves in such a steady way. Night by night, the difference is small, but over a season, it becomes easy to notice.
People long ago paid close attention to those patterns because repeating skies helped them mark seasons, planting times, journeys, and familiar rhythms of the year.
And once you begin noticing that slow turning of the sky, constellations feel even more meaningful because they become landmarks within that quiet yearly motion.
Constellations are the patterns people imagine among those stars. They help us remember the sky, turning scattered points of light into familiar shapes and stories.
One lovely thing about constellations is that people are really connecting dots in their minds, turning a wide scatter of stars into shapes they can remember.
And those shapes can be very different from culture to culture because the sky is the same, but the stories people tell beneath it are wonderfully varied.
So a hunter, a bear, or a great bird might all come from the same patch of stars, depending on who is looking and what meaning they carry.
That makes constellations feel a little like bedtime picture games, where one person sees a boat and another sees a sleeping cat in the same cloud.
But here's the deeper part. The stars in one constellation usually are not neighbors in space at all, even if they seem side by side to us.
Right. From Earth they look arranged on a flat, dark ceiling, yet some are much closer, and some are incredibly farther away.
So the pattern is real to our eyes, but it is also a kind of perspective trick made by our viewing angle from this small moving world. And even now, space is still being explored. Every telescope, rover, and mission adds another small piece to our understanding, so the story keeps unfolding. What I like about modern exploration is that it is not one giant leap followed by silence, but thousands of careful steps spread across many years.
A spacecraft may spend years traveling, then months checking its instruments, and then send home data so slowly and steadily that discoveries unfold almost like whispers.
Some missions study planets nearby, while others listen for faint signals from places so distant that the light began traveling before any human had built a telescope.
And for every answer we get, there is usually another gentle mystery waiting behind it, which keeps science feeling open rather than finished.
We still ask how common life may be, how planets form in detail, and what invisible things like dark matter and dark energy are truly doing out there.
So exploration is not only about going farther, it is also about learning to notice more, measure better, and ask wiser questions each time.
That makes space feel wonderfully unfinished, like a long nighttime path that keeps curving onward just beyond the reach of our little lantern.
That endless discovery is part of what makes the universe so special. The more we learn, the more wonder seems to remain, waiting quietly for the next question.
Wonder is such a gentle word, but it can hold a huge feeling, the kind that arises when you realize reality is stranger and lovelier than you expected.
It does not always have to be dramatic either. Sometimes wonder is simply noticing that a moon, a ring, or a cloud of dust has its own quiet story.
And the more we learn, the more detailed that feeling becomes. Because knowledge does not flatten the universe. It often makes it feel even richer.
A star is beautiful from far away, but knowing it was born will change, and may one day help create new worlds gives that beauty more depth.
So wonder is not only surprise, it is also tenderness, a soft awareness that we live inside something vast, ordered, mysterious, and still not fully known.
That is why space can make people feel both small and comforted at once. Because our questions are tiny, yet they belong inside an enormous, shared story.
And that shared story leaves us in a lovely place with the closing moments, with curiosity settling down beside rest, like starlight thinning into early dawn. Thank you for spending this gentle journey with us on Sleepy, Interesting Facts. We hope the stars feel a little nearer now, and that you can drift off feeling calm, curious, and well-rested.
And as we settle at the edge of this long journey, it helps to remember how each small fact quietly connected to the next, like stars joining into a soft path above us.
So we began with distance and scale, then drifted through planets, moons, light, dust, tools, and wonder, and somehow the universe kept feeling both larger and more familiar.
I think that is one of my favorite parts, really, that space can humble you and comfort you at the same time, asking very little, except a bit of patience and curiosity.
Even the quieter ideas stayed with me, like dust becoming worlds, or starlight taking time, or the sky changing so slowly that you almost miss the motion.
Right, and the deeper we look, the more we notice that the universe is not rushing. It builds, glows, drifts, and turns on timescales far gentler than our busy days.
If you have been listening under a blanket, or with the lights low, or with your eyes nearly closed, we hope this little voyage gave your thoughts somewhere peaceful to wander.
And if one image lingers tonight, maybe let it be this, our world moving quietly through a dark sea, while countless distant lights keep their patient watch.
Well, before we fully drift off, we do have one last gentle invitation to share. Just a small way to keep this cozy corner of curiosity growing.
So, if this sleepy little tour of space brought you some calm, you are very welcome to subscribe and join us again for another gentle wander soon.
And if you would like to help the channel in a simple way, leaving a like is a lovely little signal that these quiet facts found their way to you.
We would also love to hear from you in the comments about which fact was new to you, or which one surprised you more than you expected.
Maybe it was the patient work of cosmic dust, or the careful path of a rover, or the thought that the night sky is always changing above us.
You can keep it short and sleepy. Just a few words is plenty, and it always feels nice knowing which part of the journey stayed with you.
Until next time, thank you for listening. Rest well and let your thoughts float gently among the stars tonight.